Now, to demonstrate for birefringence, I'm going to need some special gear to do this. And we're basically going to explore what birefringence is. It's a property of some special materials, and the best example of a material that does this is calcite. So here is a calcite crystal. I'm lucky that I have one of my own, and I don't know how well you can see it, but it is a rhombohedral object. You can see that there are parallelograms on opposing faces, and it's like a cube that's been pushed over on one corner, and that corner has been chamfered, and you can see it here. This is to identify what we call the optic axis of the crystal. So if I held the crystal up, it would have a line from opposite corners, from the most oblique corners, which is this one, and the opposite one, which is that one. And you can see, I hope, this is a single crystal of calcite. It's not without its imperfections, and it is rather fragile, so I've had it for quite a long time, and I'm really mindful not to drop it. But luckily, there are two faces that are reasonably well polished that we can use to demonstrate what birefringence is. So here is just some text that I've put on a page, and if I take the calcite crystal and place it on top of the text, this is what happens. Right, so hopefully you can see that more than one image is formed just looking through. So if I change the angle, you can see I'm just resting it on the top, and we're looking straight down from above, and hopefully you can see that it forms two images. So now I'm going to do a few things that I hope will blow your mind. So the first thing is, if I rotate this crystal about its position, laying flat on the surface of the paper, what do you think might happen to these two images? All right. You may not have a clue. You may actually know. But let's actually just, so if you have a think for a second, even if you pause the video, have a think what you think what possibilities are, and then restart the video and let's do it and see what happens. So if I take the crystal and I rotate it, what can you see happening? Well, it looks to me like one image is rotating with the crystal and the other image is staying perfectly still. And if I lift the crystal up or shift the crystal across, which image is the one that's not moving? The one that's not moving is the original one. So it's forming this secondary image, and the secondary image is the one that's rotating. Now, if I maximize the difference between the two, which I hope you can see there, now something interesting happens. So if I take a polarizing sheet, and here is one here, I can rest the polarizing sheet on the top, and watch what happens to the two images when I have this polarizing sheet. So let's get it right. So there's the polarizing sheet out of the way. Here's the polarizing sheet. And if I rotate the polarizing sheet around, watch what happens. Oh, it's interesting. So when the polarizing sheet is in that orientation, we get one image, and then when I rotate it 90 degrees, we get the other image. So it's actually selecting between the two images. What does the polarizing sheet do? The polarizing sheet lets light of a particular polarization go through it. So with the polarizing sheet, we're actually selecting the two images, and it's completely selecting the two images. So that tells us that the light from each of those two images are, one, polarized, and two, polarized orthogonally to each other. How about that for awesome? And birefringence as a phenomenon is super critical. And of course, it's been, so the original kaleidoscopes that you used to be able to get as a kid's toy, used little crystals within them that were birefringent, that allowed really exotic patterns to form. And it's even used in a lot of important optical devices, which is what we're going to talk about after we go through the theory of birefringence. Okay, thank you kindly.